Hello. Now we are going to look at the area and circumference of circles, and in connection with that we're going to look at arc length and the area of sectors, and they're just parts of circles. So let's have a look at what we know about the language of circles. So this is a new shape, and because it's a slightly more complicated shape to talk about mathematically, we're actually going to look at the log tables for this. So the formula tables that we'll have on our exams, and we're looking at page 9, and initially it's the bottom of page 8 and then the rest of page 9 that has information on circles for us. So page 8 and then more importantly page 9 for the arcs and the sectors. So that's where we're looking if we are stuck on what tools we have available to us for circles, page 8 and 9 in our formula tables or log tables. Now let's have a look here. So we have a circle. We recognize we've got a circle. Anytime we have a circle, always try to draw in the center of the circle, because so much of what is going to be complicated about circles in the long run will revolve around understanding where you have the center and stuff going out to the edges, so radii or diameters. So as that's where we need to end up, that's how we're going to train ourselves to begin with. So we have our circle, we draw in the center, and then from the center out to the circle in a straight line is or the radius. And D here, the blue dashed line, is going all the way from the circle through the center and back to the circle again. And it's called the diameter, and it's twice the radius. Why is it twice the radius? Because that's a radius line and that's a radius line. So there are two radii that make up a diameter. In terms of the circumference, one of the things we're looking at today, it is the distance all the way around the circle, which we would often call the perimeter of a shape, but it has a special name for circles. It's called the circumference. So we're going to go all the way around the circle, and that length is the circumference, and it's given by the formula 2 multiplied by a number called pi multiplied by the radius. So pi is a special number. It's approximately 3.14. So it's approximately 3.14. That means approximately equal to 3.14. And sometimes in questions you'll be asked to write it as 3.14. Sometimes you'll be asked to use the, if it doesn't mention it, it means for you to use the pi button on your calculator, which is usually the second function or shift button, and then down the bottom of all of your calculator buttons near the equal sign, you will see pi printed on one of your buttons. Usually that's where it is, depending on your calculator. So again, second function or shift, and then down on the bottom row near the equal sign, you will see that symbol, and that's what you press to get pi if you are putting it in without writing it as the number 3.14. It's actually a decimal that goes on forever, which is why we have a special button for it on our calculator. All right, so we have the circumference is 2 times pi times the radius, and it's roughly like the perimeter of our total circle. And we also have the area of the shape. So we talked about the circumference, and we also have the area. And the area of our circle is equal to pi, that 3.14 number, multiplied by the radius squared. So those are two very important formulas that keep coming up in circles all the way through our work with them. Connected with them, so this is the circumference, so the distance all the way around a complete circle, and this is the area of a complete circle. But we can also deal with fractions of circles. So if, instead of going all the way around, if we only went around by a particular angle, which we've called theta here, a 0 with a squiggle through the middle is called theta. It's just a way of labeling an angle. So our angle that we have gone through here is a particular fraction of the total circle. We know that there are 360 degrees in a complete circle, in a complete rotation. If I started here, rotated all the way around back to the same point, I'd have rotated through 360 degrees. So when we're looking at chunks of circles, effectively pie slices of our complete pie or our complete cake, we are talking about sectors or arcs. So a sector is in green here, and it is the area of this fraction of a circle. And the arc length, which unhelpfully is also called L in the log tables, is the fraction of the circumference that we have gone around. So arcs and sectors are just the fractions of bigger circles. They're just fractions of circles. Either a fraction of the circumference of that complete circle or a fraction of the area of that circle. And in terms of their formulas, they work exactly as you'd expect based on what they are. The arc length, L, is the fraction of the complete rotation you've gone through. So theta is our angle. We've gone through this many degrees out of a total of 360. So this many degrees out of a total of 360 of our circumference, our 2 pi r. And the sector formula, the sector is the area, remember? So the area of our sector is the fraction of the complete circle that we have gone through. Then there's some extra bits of language that we should just mention in case they come up. If you see a line that just touches off a circle, so it barely scratches a circle, it only touches it at one point or crosses it at one point, that's called a tangent line. And in the long run, they'll be extremely important. There are a lot of interesting things that happen with tangent lines. But for right now, we know that a tangent line is a straight line and it crosses the circle at only one point. So it only just hits the circle at a single point. And then these two you can come across as well. A chord is a line that goes through the circle, but it doesn't go through the center. Well, if it went through the center, we would call it a diameter line. So a chord is a line that's just cutting a bit off of the circle, and then the area that gets cut off of the circle is called a segment. So a segment is area, and chord is a line that's cutting the circle. Let's get into some practical examples. So we have a circle here, and we're told that it has a diameter. I can see the line going all the way from here through the center out to the circle again. So that's a diameter, is 10 meters, and I want to find the area and the circumference. Well, if I recognize a shape, and I do here, I'm going to write down the formula for that shape. I'm told to take pi as 3.14. So I know the area is going to be pi r squared, and I know that the circumference, the other thing I'm asked for, is going to be 2 pi r. So when I use that, so let's look now. We have our formula written down. We recognize we had a circle. We're going to write down our formula. Now what can we do? Well, I'm going to say I have the center, and I know that I'm always going to be interested in the radius. So what would be the radius of this circle? Well, if the diameter is 10, and I know that that's equal to twice the radius, well then I can just divide both sides by 2, and I know that the radius must be equal to 5 meters. So now I've put in on my diagram that the radius must be 5 meters, so I can see the information that I've got. So at that point, all I have to do is, that was the only thing I didn't know. I can see in this formula, pi is just a number I have in my calculator, or in this case, I'm going to write it down as 3.14. So the radius was the only thing I needed. I've now got that. So I deal with my area, it's pi r squared, and I know my radius, or r, is 5 meters. And I know my circumference, which we call L in our log tables, or formula tables, is 2 times pi times the radius, and I know the radius is 5. So I've written down my formula, I've written down the information I got, I've put it on my picture so I can see everything clearly, and now I'm going to sub in. The area is equal to, I'm told to take pi as 3.14, so that's what I'm going to do. 3.14 times 5 squared. So when I put that into my calculator, I get 78.5 meters squared, because this is the area of our sector, of our circle, I apologize. And then the circumference is 2 times, I'm told to take 3.14 as my pi, times 5, ends up being 31.4 meters, because this is a length. So let's continue on now. I'm told that L is 30 centimeters for this circle. Now I don't like a circle without a center, so I'm going to estimate the center is there. And I know I want to know about the radius of a circle. So can I work out the radius? Well, that's actually what I'm asked for. I'm not told anything about pi here, so I'm going to use the pi button on my calculator, the second function, and then the bottom row, I can see that pi symbol. So I'm asked for the radius. I'm told the circumference, L, so I know that I write down the formulas when I recognize them. And I have a circle, so I might also write down, if I got stuck, I might also write down the area formula, but in this case I don't think I need it, but it's better to have it there so I can see it's available to me. And I know L is 30 centimeters, and the only thing I am missing then is OR. So OR is what I'm looking for. So 30 in for L is equal to 2 times pi times the radius. So 30 is equal to 2 pi, or I want to get OR by itself, so I need to divide both sides by 2 pi, because 2 pi divided by 2 pi is 1, and that'll leave me with 1 radius, which is what I want. So when I put that into my calculator, I get 4.7746. We go to 4 decimal places when we're in the middle of a question, and then we're asked to round to 1 decimal place. This will often come up in these questions, so we need to keep an eye to it. And rounding, because that's a 7 there, I'm going to round up to 4.8, and this is centimeters for my radius. Find the area and the total perimeter to 1 decimal place. What type of thing have I got here? I've got a sector. So I'm going to write down my formulas when I see that. Theta all over 360. I'll write them down. Now the radius, I can see from my picture, is 4 centimeters. The angle, which is theta, is going to be 100 degrees. That's given to me in here. So that's all I need. I can now sub in, but I actually need to be quite careful of something in this question. The total perimeter. Well, this formula here doesn't give me the total perimeter. It gives me this length here. It gives me the arc length. That's what L is. So to get the total perimeter, I'm going to need to be careful. It's going to be 4 plus 4 plus the length. 4 plus 4 plus the arc length. So watch out for that if we see perimeter in a sector type question. We have to go all the way around, not just the arc length, not just the curve length. As I've started this, I may as well continue. So I need to find L. Is going to be my theta all over Earth 360, so 100 over 360 times 2 pi on 4. And I'll sub that in now. I get 6.9813. Again, go to 4 decimal places. Rounding, that means I would go to 7 centimeters. And then I'd have my perimeter would be 4 plus 4 plus 7, which is going to add up to 15 centimeters. And the area, I'm just going to sub into my formula. And that gives me 14. I have to round up again to 14, and this is going to be centimeters squared. Finally, I have a sector, so I write down my formula for my sector. I write down my formula, I write down the information given to me, and I can see I can sub into this formula in order to find theta. Subbing into my formula, I am now able to simplify and rearrange. Simplifying, a common factor of 36 top and bottom, and then multiplying by 10 and dividing by pi leaves me with theta is 120 degrees. And that's what we need